A ski jumper is moving 28 meters per second when they reach the bottom of the ramp that launches them into the air at 12 degrees above the horizontal. The ground continues to slope downward after the jump, and as a result, the skier lands 15 meters below the launch point. How far has a skier traveled horizontally before touching the ground? So you want to make sure you definitely have a picture for this one because it can be a little confusing of where you're putting all of your numbers. So here's my ski jump. Ski jumper goes down and it's going to be shot upward and to the right at 12 degrees above the horizontal with a speed of 28 meters per second. So 28 meters per second is my hypotenuse. There is going to be a velocity in the x direction. There's going to be a velocity in the y direction, and we will find those in just a moment. Be aware that the ground is going to continue to slope downward. So when they land down here, it's going to be 15 meters below the takeoff point when they became a projectile. So the displacement is going to be 15 meters down in the y direction, and we're trying to find how far the displacement goes to the right before they land. So that's the ultimate question. Pulling some of our numbers out, displacement in the x is my question mark. Velocity in the x direction we don't have, but we'll solve it in just a moment when we do our SOHCAHTOA right triangle geometry. In the y direction, I know my displacement is negative 15 meters. Initial velocity in the y direction, again, we'll solve for that in just a moment when we do our right triangle. The acceleration, as always, is negative 9.8 meters per second squared. So now let's do that sine and cosine in order to solve for the velocity in the x and velocity in the y. We'll do velocity in the x first. That's the adjacent side in this particular triangle, which means we're going to be using the cosine. So to solve for velocity in the x, it's the cosine of our angle, which is 12 degrees, multiplied by the hypotenuse velocity, which is 28 meters per second. When I plug that into my calculator, I get that the velocity in the x is 27.4 meters per second. So that's the amount of speed that we're going to have to the right. And in the y direction, we're going to do the exact same process, but instead of cosine, we'll use sine because it's the opposite side of our triangle. So the initial velocity in the y is sine of 12 degrees times 28 meters per second. And when I plug that into my calculator, I get 5.8 meters per second. That's going to be a positive 5.8 because it is upward. So 5.8 meters per second for the initial velocity in the y direction. If we try to solve for displacement in the x direction right away, we don't have enough information. So if we try to do displacement in the x direction, d in the x is equal to the velocity in the x multiplied by the time. We have the velocity is 27.4, so if we just could get time, this would be a very easy problem to do. But we do have enough information in the y direction to solve for time, so we'll solve for time in the y, use it in the x, and get our final answer. So in the y direction, if I'm solving for time, I'm going to pick the equation without VF in it. That's d equals v naught t plus 1/2 at squared. D is not 0, v naught is not 0, so nothing cancels, which means we have to do the quadratic formula to solve for time. We've seen that before. This equation, rearranged for time using the quadratic formula, gets us time equals negative v naught plus or minus the square root of v naught squared plus 2 AD all over A. We can now plug in our numbers and solve for time. So time equals negative 5.8 meters per second plus or minus the square root of 5.8 meters per second squared plus 2 times negative 9.8 times the d, which is negative 15 meters. All of that is divided by negative 9.8 meters per second squared. Like every time we use the quadratic formula, we're going to get two possible answers. One of them is going to be positive, the other one's going to be negative. So we plug in. One of our possible times is 2.4 4 seconds. And then the other possible time when we plug back in is going to be negative 1.25 seconds. We don't use negative time here in physics. It doesn't make any physical sense to use negative time. So while we solved it, we're not going to use it. We're only going to use the 2.44 because it's the only time that makes actual physical sense. So that's going to be the time here in the x direction, 2.44 seconds. I can now very easily solve for the displacement in the x. I just have to multiply the velocity, which we solved at the beginning, 27.4 meters per second, multiplied by the time, which is 2.44 seconds. And when I plug that into my calculator, I find a horizontal distance of 66.8 meters for the ski jumper.